Hey math enthusiast, I'm here to go over the notes for section 9.7 dealing with dilations. So first let's define that term dilation. So it's a type of transformation that is either going to stretch or shrink my figure. All right, a lot of people associate dilation with eyes. Okay, so pupils might be dilated, meaning that they're either smaller or larger than normal. The center of dilation, it's very similar to our center of rotation. So that's going to be a fixed point about which the figure is either enlarged or reduced. So that point that it's growing from or shrinking to. So if you think about your pupils dilating, the center of dilation would be the center of your pupil. All right, that's where it's growing from or shrinking to. Scale factor for dilation is going to be the ratio of the side lengths of the image compared to the side lengths of the pre-image or the original figure. All right, scale factor is typically represented with the letter K. So what's going to happen is my points are going to change from x, y, and then all of a sudden when I apply the scale factor, it's going to be multiplied by that. So it's going to be k times x and k times y. And you'll see that in some of our examples in a little bit. Now, if that scale factor is between 0 and 1, that means the dilation is a reduction. The figure is going to get smaller. Maybe it's half, maybe it's a third. If the scale factor is greater than 1, then the dilation is going to be an enlargement. It's going to get bigger. Maybe 2 times the size, maybe 10 times the size. Now, if that scale factor happens to equal 1, it's going to stay exactly the same. It's not going to get any bigger or smaller. All right, so just imagine you're multiplying numbers by 1. They're not going to change. They're going to remain exactly the same. For our first example, we're asked to find the scale factor of the dilation. I also want to figure out whether it's a reduction or an enlargement. So for problem A, it looks like we have 2 pencils. So here's my pre-image marked as P and my image marked as P prime. So I can tell right away without applying any equations or any math that this is definitely an enlargement. My image is definitely larger than my pre-image. Now, next thing I want to figure out is the scale factor. So in order to determine what K equals, if you remember from our notes, what I have to do is compare the image to the pre-image. Now, in this case, I'm not sure of the exact length, so what I'm going to do is going to compare the center to the image. How far away is that? And then compare the center to the pre-image. How far away is that? So in this case, it looks like from C to P prime, the center to the image is 10. The center to the pre-image is 6. For scale factor, I typically want to reduce it as much as possible because it's a ratio. So my scale factor is 5 to 3. So what that essentially tells me right here is that for every 5 units on the image, it's only going to be 3 units on the pre-image. Now for B, let's start off and identify our image and our pre-image. So this ruler on the right is my pre-image because it's labeled P, and my image is this ruler right here labeled P prime. So right away I can tell that this is a reduction. My image is definitely smaller than the pre-image. P prime is definitely smaller than P. So next thing I want to do is figure out my scale factor. So let's think about what I did for number 1. So I was comparing the distance from the center to the image, P prime. Compare that to the center to the pre-image, P. So now I just have to pick out those lengths. So from C to P prime, is only 24 because it's a reduction. It got closer to my center. But the original from C to P is 40. Originally it was 40 units away. It shrunk, and then it was only 24 units away from the center. Once again, for my scale factor, I want to try to simplify that as much as possible. Looks like I can divide both terms by 8, which is going to give me 3 to 5. Once again, what that scale factor is telling me is that for every 3 units on the image, it's going to be 5 units on the pre-image. For the next example, once again, I'm asked to find scale factor. I want to tell whether it's a reduction or enlargement, and I want to find the values for all the variables. Let's start off with that second part. Is it a reduction or enlargement? So once again, this is my image, this larger triangle, P prime, to the left. And my pre-image is P, which is the smaller triangle to the right. So remember, we're going from P to P prime. So it looks like right away it's going to be an enlargement. It's definitely getting bigger. And I can see that if I compare these two side lengths. So we went from 5 to 12.5. Next thing I want to figure out is what's my scale factor? All right, so let's compare the two side lengths that I pointed out. So I want to compare a side length in the image to a side length in the pre-image. So those side lengths are 12.5 and 5. All right, I picked those two because they obviously correspond to one another, and those are the only two sides that I have that correspond. All right, I do have 4 here, which matches up to y, but that doesn't really help because we have a variable. And then I do have 8 here, which matches up to x. But once again, that doesn't really help because we have a variable. So now I'm dealing with a decimal. As I said, I want to try to reduce these scale factors as much as possible. It's a little challenging to reduce with a decimal. So what I'm going to do is I'm actually going to multiply by 2 to start. And now that's going to get rid of that decimal. So I end up with 25 over 10. Now I should be able to reduce this. If I divide both terms by 5, I end up with 5 over 2. Okay, so there's my scale factor. Now what I need to do is actually solve for these variables. So in order to do that, I am going to set up a proportion. So I'm going to use my scale factor, 5 over 2. So once again, remember the 5 came from P prime and the 2 came from P. And to complete my proportion, let's focus on x first. So for x, it corresponded to 8. Now, x is coming from my image P prime. So I'm going to place x on top on the other side of my proportion. And 8 is coming from the pre-image. So I'm going to place 8 on the bottom, which corresponds with the pre-image. Now I have my proportion set up. In order to solve this proportion, I'm going to cross multiply. So I end up with 2x equals 40. So it looks like x equals 20. Now, if you're not sure if that's correct, all you have to do is just take that value and plug it in and check to see, okay, well, 20 over 8, that is going to reduce down to 5 over 2. So I am going to get the same scale factor even if I compare those two values. Last thing I want to do then is solve for y. So I'm going to stick with the same ratio, same scale factor, 5 over 2. Remember, this is your P prime, and this is coming from your pre-image P. And to complete this proportion, now I'm going to focus on my last two sides, y and 4. So remember, y is coming from the image, So I'm going to put y on top on the other side of my proportion. And 4 is coming from the pre-image. Now that my proportion is complete, I am going to cross multiply. So we end up with 2y equals 20. So it looks like y is going to equal 10. And once again, I can double check to make sure that's correct. If I plug it back into this ratio, I end up with 10 over 4, which is going to reduce down to my same scale factor, 5 over 2. So all the side lengths, when I compare them, will always have the same scale factor. 5 to 2, 5 to 2, and 5 to 2. For example number 3, we're dealing with triangle FGH. So now that we've plotted our pre-image, next thing I want to do is perform a dilation centered at the origin, and it's going to have a scale factor of 5 over 2. So if you remember what we said earlier in the notes, if I want to dilate a figure and it's centered at the origin, what I'm going to do is I'm going to take my points and I'm going to multiply them by my scale factor. So, for example, if I'm starting off with point F, if I want to get to F prime, what I'm going to do is I'm going to take my scale factor, 5 over 2, and I'm going to multiply it by the x value, and my scale factor 5 over 2, and I'm going to multiply it by the y value. And then I'm going to have to repeat that for my other 2 points, G and H. Now that I have my points set up, finally I just want to simplify them. Now you can write them as decimals, you can keep them as fractions, it's up to you. It looks like f prime is going to end up at negative 5 over 2, negative 5 over 2. Or if you want to change it to a decimal, I know each of those are going to be 2.5. So it's going to be negative 2.5, negative 2.5. Next thing we have is g prime. Looks like I'm going to end up at 0, comma 5. And lastly, we have h prime, which is going to end up at 5, comma 5 over 2, or 2.5. Finally, I can graph my image. So now I've plotted f prime, g prime, and h prime. Definitely appears that it is an enlargement. My image is definitely bigger than my pre-image. And I knew that going in because my scale factor, 5 over 2, was greater than 1. So I knew my final image was going to be bigger. Now number 4 is very similar. I'm dealing with triangle MNL, and I want to dilate it. First, let's figure out where my coordinates are. Now I'm going to do the same thing I did for the last example. So anytime I'm dealing with a dilation on the coordinate plane and it's centered at the origin, all I have to do is I have to take my points and I have to multiply them by my scale factor. Now in this case, my scale factor is 2 over 3. So I know right away it's going to be a reduction. My image is going to be smaller than my pre-image. So now let's go through and apply this scale factor to all my points. So for m prime, it's going to be 2 over 3 times the x value and 2 over 3 times our y value. We can try to simplify that first to start. So I know m prime is going to end up at negative 2 over 3, comma 4 over 3. So not the easiest point to graph, but we'll figure it out. N prime, I'm going to write that one off to the left. So it's going to be my scale factor, 2 over 3, times the x value for n, and my scale factor times the y value for n. So it looks like for n prime, we're going to end up at 4 over 3, comma 8 over 3. Lastly, we have L prime. So my scale factor, 2 over 3, times the x value, 6, and my scale factor 2 over 3 times the y value 0. So lastly, it looks like L prime is going to end up, looks like we end up with 12 over 3, which is going to reduce right down to 4. 4, 0. Finally, I can graph my new coordinates. So I did my best plotting some of those fractions, but it looks like, as I said, it's definitely a reduction. So m prime, n prime, and L prime, when I connect it, should appear smaller than my original figure m, n, L. For number 5, I'm dealing with triangle ABC with the coordinates they give me. And in this case, I want to perform a composition of transformations. Now I want to go in the order that they're listed. So first thing I want to do is a dilation centered at the origin with a scale factor of 3. So in this case, I'm going to take my coordinates, x, y, and I'm going to multiply them by that scale factor. So 3 times x and 3 times y. So first that's going to give me a prime, b prime, and c prime. So I'm going to list them right down below here. So a prime is going to be 3 times 1. And for my y coordinate, it's going to be 3 times 2. B prime is going to be 3 times 5. And for my y coordinate, it's going to be 3 times 4. And lastly, C prime, for my dilation, it's going to be 3 times my x coordinate, 7, and 3 times my y coordinate, 1. So in this case, at least I don't have to deal with any fractions. I'm going to get whole numbers for all my final answers. So A prime is going to end up at 3, 6. B prime is going to end up at 15, 12. And lastly, C prime is going to end up at 21, 3. Okay, next thing I want to do is reflect all of these over the x-axis. So this is my second transformation. So let's jot down what is the rule for a reflection over the x-axis. So what's going to change is my y coordinate. So now I want to apply this rule, this reflection rule, to my coordinates down here, a prime, b prime, and c prime. So this is going to give me my final points that I'm going to write down in blue, a double prime. So the only thing that's going to change, remember, is just the y coordinate is going to change signs. So I'm going to go from 3, 6 to 3, negative 6. B double prime is going to move to 15, negative 12. C double prime is going to move to 21, negative 3. And there's my final coordinates for A double prime, B double prime, and C double prime after this composition of transformations. Number 6 is very similar. I'm dealing with triangle RST. I want to find the double primes after a composition of transformations. So first thing I'm doing is the dilation again. It's centered at the origin, but now my scale factor is 1 over 2. So I know that when I'm finished here, it's going to be a reduction. So in order to reduce it, I'm going to multiply my x coordinates by that scale factor of a half. So let's jot down our first coordinates, r prime, s prime, and t prime with this scale factor applied. So it's going to be a half times negative 2 and a half times negative 2. For s prime, it's going to be a half times 0 and a half times 2. And lastly, for t prime, it's going to be a half times 4 and a half times 2. Now I can come up with my new points, r prime, s prime, and t prime after this dilation. So we end up with r prime at negative 1, negative 1. S prime is going to be at 0, 1. And t prime is going to be at 2, 1. After that, I want to perform the rotation. So this is my second transformation, 180 degrees about the origin. They don't specify which direction because it doesn't matter if you're going 180 degrees. It could be clockwise or it could be counterclockwise. They're both going to end with the same result. But what we really need is the rule. So if I'm going to rotate a figure 180 degrees about the origin, remember the rule is negative x, negative y. So both your coordinates are going to change signs. So that means our double prime is going to move to positive 1, positive 1. S double prime is going to move to 0, negative 1. And T double prime is going to move to negative 2, negative 1.